A box starts from rest and slides down at 28 degrees incline 85 meters long. If the ground is level at the foot of the incline and has a coefficient of friction of 0.09, how fast does the box slide at the base of the incline? From the previous lecture video, we defined and applied the principle of the mechanical conservation of energy with just the presence of the conservative forces. And now, we will talk about the energy conservation that involves the non-conservative forces. Non-conservative forces change the amount of mechanical energy in a system. Pwede nilang pababain yung mechanical energy by converting it to thermal energy, or pwede rin nilang i-increase by converting the work to kinetic or potential energy. In some systems, both types of processes occur at the same time. In physics, meron tayong tinatawag na law of conservation of energy. Isa sa mga great experiment of physics is that whenever energy is transferred or transformed, it is found that no energy is gained or lost in the process. And ito nga tinatawag natin na conservation of energy. This is one of the most important principles in physics. And according to this law, the total energy is neither increased nor decreased in any process. Energy can be transformed from one form to another and transferred from one object to another, but the total amount remains constant. As I have said earlier, na-discuss na natin yung conservation of mechanical energy, yung ganong system involving conservative forces, and nakita natin how it could be derived from Newton's laws and thus inequivalent to them. But in general, yung validity of the law of conservation of energy na nag-encompass on all forms of energy including those associated with non-conservative forces like friction and other types of non-conservative forces, and nagre-rely on experimental observations. From our previous lecture video, do sa applications natin ng conservation of energy and sa mga problems na na-encounter natin, kadalasan nine-neglect natin yung friction and other non-conservative forces. But in many real-life situations, hindi natin sila basta-basta pwedeng i-ignore ng ganun na lang. In natural processes, yung mechanical energy as the sum of the kinetic and the potential energies does not remain constant but decreases. Because one example nga yung frictional forces reduce the mechanical energy but not the total energy. Yun yung tinatawag natin na dissipative forces. Now, para mas makita natin yung connection between the work done by non-conservative force and yung mechanical energy, let's go back to the work energy theorem, which says that yung total work is equal to the change in kinetic energy. And recalling that yung conservative work naman is related to the change in potential energy by this equation, suppose for instance yung system has one conservative and one non-conservative force. In this case, yung total work is the sum of the conservative work and the non-conservative work. So we have this equation. And by solving this relationship for the non-conservative work, we have here work total equals work done by conservative plus work done by non-conservative. Again, ang total work natin is equal to the change in kinetic energy by the work energy theorem, and yung work done by conservative force naman is equal sa negative change in potential energy plus work done by non-conservative force. And if we're going to derive the equation for the work done by non-conservative forces, we will get this equation. And finally, since yung total mechanical energy natin is equal to simply the kinetic energy plus the potential energy, it follows that yung change in mechanical energy is delta E equals delta PE plus delta KE. And as a result, yung non-conservative work is simply the change in mechanical energy. Work done by non-conservative force is equal to change in energy natin, and this is just equal to energy final minus the energy initial. If more than one non-conservative force acts, we simply add the non-conservative work done by each such force to obtain the work done by non-conservative forces. And at this point, mas magiging useful to collect the three working relationships that have been introduced in the last two chapters. This one, and etong part na to, as well as this one. So mapapansin natin na yung positive non-conservative work increases the total mechanical energy of a system, while yung negative non-conservative work naman decreases the mechanical energy, and i-convert niya yon to other forms. Example number 1. A 17-gram giant leaf falls from a tree and drops straight to the ground. If its initial height was 5.3 meters and its speed just before landing was 1.3 meters per second, how much non-conservative work was done on the leaf? Say for example, this is our tree, and ito yung giant leaf na nahulog. From here, ito na siya. So this is the initial position, and this is the final position ng giant leaf. And since nahulog siya from rest, ang velocity natin dito initial is equal to 0, and at this point, before siya lumapag dun sa ground, meron siyang final velocity na 1.3 meters per second. Yung leaf natin nasa height of 5.3 meters. Say, this is the reference natin. Ang y initial natin is equal to 5.3 meters, and ang y final natin is equal to 0. Work done by non-conservative force is equal to the change in the total mechanical energy, and this is just equal to energy final minus the energy initial. Work done by non-conservative force ang mismong hinahanap natin na nai-apply dun sa leaf. Ang energy final natin is equal to 1/2 times mass times final velocity square plus mass times gravity times y final, and minus 1/2 times mass times the initial velocity square plus mass times gravity times y initial. Again, 0 yung ating initial velocity, so this is 0 na agad. And yung final position natin is 0, so this is 0. Ang natira sa equation natin is 1/2 times mass times velocity final square, and this is negative, so magiging negative na tong part na to, minus mass times gravity times initial position. And we just have to substitute the values. Work done by non-conservative force is equal to 1/2. Ang mass is, we have 0.017 kilograms times 1.3 meters per second quantity square minus 0.017 kilograms times 9.81 meters per second square as our gravity times the initial position natin na 5.3 meters, and by calculating, ang value ng work done by non-conservative force natin is equal to negative 0.8695 joules, or simply this is negative 0.87 joules. In this problem, most of the leaf's initial mechanical energy is dissipated as it falls. Nagkaroon na siya ng loss. And isang factor na nga dun is yung air resistance na naramdaman ng giant leaf. So this is example number 1. Example number 2. A 16 kilogram child descends a slide of 2.2 meters high and starting from rest reaches the bottom with a speed of 1.25 meters per second. How much thermal energy due to friction was generated in this process? Let's draw the figure. So this is the slide, this is the child, and this is the initial position. This is the final position. Ito na yung child after niya mag-slide. The height of the slide is equal to 2.2 meters. And from here, sa initial velocity, we have 0. And ang y initial natin is equal to 2.2 meters. Sa final position, ang velocity na niya dito is equal to 1.25 meters per second. And ang final position naman natin, say this is the reference, itong part na to, ang y final natin is 0. Now the question is, ang hinahanap sa atin is yung thermal energy due to friction was generated in the process. Ibig sabihin, yung thermal energy na yan is increased dun sa total energy niya. Ibig sabihin, at this point, sa final natin makikita yung thermal energy na hinahanap. Meaning, kung walang friction, energy initial natin is equal sa energy final. Pero dahil may friction, and yung friction na yun is nakapag-produce ng thermal energy, nagkaroon tayo ng increase dun sa total energy. Meaning, meron na tayo ditong i-add na thermal energy. And by this equation, masolve natin yung yung thermal energy na na-produce ng friction. So, ang initial energy natin is, wala tayong spring again. So, this is just kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final plus the thermal energy. So, we have here 1/2 times mass times initial velocity square plus mass times gravity times y initial equals 1/2 times mass times final velocity square plus mass times gravity times y final plus the thermal energy na hinahanap sa problem. Ang initial velocity natin is already 0 and ang y final natin is 0 na din. So natira sa equation natin, we have mass times gravity times y initial equals 1/2 times mass times final velocity square plus the thermal energy produced by the friction. And by deriving the equation to solve for the thermal energy, we have now mass times gravity times the initial position minus 1/2 times mass times final velocity square. By substituting the values, lagay na natin dito, thermal energy is equal to, ang mass natin is 16 kilograms times 9.81 meters per second square times the initial position we have 2.2 meters minus 1/2 times 16 kilograms times the final velocity na 1.25 meters per second quantity square. By calculating, ang thermal energy natin is equal to 335.31 joules. This is the energy na na-produce ng friction. Friction again is one of the non-conservative forces. So this is example number 2. Example number 3. A box starts from rest and slides down at 28 degrees incline 85 meters long. If the ground is level at the foot of the incline and has a coefficient of friction of 0.09, how fast does the box slide at the base of the incline? Para mas ma-visualize, i-draw ulit natin. So this is the incline with inclination angle of 28 degrees and this is the box. Yung box has a weight of, ayan, and of course meron siyang normal force dito. Kung dinodraw natin yung mga forces, and meron tayo ditong force of friction na nararamdaman dun sa surface. So this is the initial point and this is the final point. Nag-start siya from rest, again, ang initial velocity natin is 0. Ang distance ng incline is, ito, from here hanggang dito, we have 85 meters long. So this is a reference. Sa final natin, ang inanap natin is yung final velocity and ang y initial natin, hindi natin alam. Pero given sa atin yung distance ng inclination natin and masasolve natin yung initial position natin by trigonometry. And since this is a reference, ibig sabihin yung y final natin is 0 na agad. Kaya lang, given sa atin ng friction, ibig sabihin magkakaroon tayo ng work done by the friction. So saan natin ilalagay yan? Again, like the previous example natin, yung example number 2, i-add natin siya dun sa final energy. So we have energy initial equals energy final and this is equal to work done by the force of friction. Kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final plus work done by the force of friction. 1/2 times mass times the initial velocity square plus mass times gravity times initial position equals 1/2 times mass times the final velocity square plus mass times gravity times y final plus work done by the force of friction. Again, 0 ang ating initial velocity and 0 din yung ating final position. We have now here mass times gravity times initial position equals 1/2 times mass times final velocity square na siyang inahanap plus work done by the force of friction. Take note that yung work natin is just simply equal sa force times the distance. So, ibig sabihin yung work done by the force of friction natin is force of friction times the distance na na-travel niya. So, pwede na natin itong i-substitute. Mass times gravity times initial position equals 1/2 times mass times final velocity square plus force of friction times the distance. Take note na magkaiba yung distance natin at yung y initial. Yung y initial natin is simply the height. Ito siya. Ito yung ating y initial. Yung distance naman natin is yung slant. We have 85 meters. Yan yung total distance na ilalagay natin sa force of friction. Another, hindi pa natin alam yung mismong equation for the force of friction. Force of friction again is simply equal to the coefficient of friction, which is coefficient of kinetic friction, times the normal force. Pwede na natin itong ilagay ngayon sa equation. Lipat na natin dito. Mass times gravity times initial position equals 1/2 times mass times final velocity square plus coefficient of kinetic friction times the normal force times the distance. But another thing na hindi natin alam is yung value ng normal force. Pero pwede natin siyang i-derive. Ang normal force natin by free body diagram. So, i-draw natin ito. We have, ito yung ating normal force. Yung weight natin is nandito na siya. And we have an angle na 28 degrees. Here, ito yung ating normal force. Ito yung ating weight. Ibig sabihin, normal force is directly equal sa weight cosine theta. And ang normal force natin is mass times gravity times cosine theta. Pwede na nating ilagay ito ngayon sa equation. Mass times gravity times initial position equals 1/2 times mass times final velocity square plus the coefficient of kinetic friction times mass times gravity times cosine theta times the distance. So from our equation, pwede na nating i-cancel yung mass. Ang matitina lang sa atin is gravity times y initial equals 1/2 times final velocity square plus coefficient of kinetic friction times gravity cosine theta times the distance. Solving for the final velocity, 1/2 times final velocity square equals gravity times y initial minus coefficient of kinetic friction times the gravity cosine theta times the distance. Multiply natin magkabilang side by 2 para makancel ito and square root ng magkabilang side para makancel yan. Final velocity is equal to the square root of gravity times y initial minus coefficient of kinetic friction times gravity cosine theta times the distance times 2, yung buong quantity na yan. Kaya lang, another thing na hindi pa tayo alam is yung value ng y initial. So for y initial, ito yung ating incline, ito yung distance, and ito yung y initial, ito yung angle natin. Simply, yung y initial is equal to, by sine function or by SOHCAHTOA, this is d times sine theta. Ito na ngayon ilalagay natin for y initial. Velocity final is equal to the square root of gravity times d sine theta minus coefficient of kinetic friction times gravity cosine theta times d quantity times 2. Ito na ngayon yung ating magiging huli equation to solve for the final velocity. And let's continue to the next page. By substituting the given values, final velocity natin is equal to the square root of 2 times 9.81 meters per second square times ang d natin is 85 meters sine 28 degrees minus coefficient of kinetic friction na 0.09 times 9.81 meters per second square cosine 28 degrees times ang d natin is 85 meters. And by calculating, ang final velocity natin is equal to 25.5 meters per second. So in this problem, we applied a lot of principles from the Newton's laws of motion to the energy conservation hanggang dun sa involved na nga yung friction as the non-conservative force. So this is example number 3.